Measurements of fluvial sediments are often necessary to complement sediment transport and sediment yield studies. The accuracy of the measurement is dependent not only on the equipment and techniques used, but also on the application of basic principles of sediment transport. As sediment enters a stream or river, it separates into bed material load and wash load. In turn, the bed material load is transported as either A, bed load, or B, suspended bed material load. The sum of suspended bed material load and wash load constitutes the suspended load of the stream or river. The term sample suspended load is used to describe the fraction of suspended load that is possible to sample with available equipment. It excludes the unsampled suspended load, that is, the fraction of suspended load that is carried too close to the stream bed to be effectively sampled. The sum of sampled and unsampled suspended loads is the total suspended load. Since 1939, sediment sampling equipment has been developed and supported by the U.S. Federal Interagency Sedimentation Project. Sediment sampling equipment is of three types. 1. Suspended sediment samplers. 2. Bed material samplers. 3. Bedload samplers. Suspended sediment samplers are of two types. 1. Depth integrating and 2. Point integrating. Depth integrating samplers accumulate a water sediment sample in a pint-sized bottle as the sampler is lowered to the stream bed and raised back at a uniform rate of transit. These samplers are designed to assure that the velocity in the intake nozzle is nearly equal to the local stream velocity. Samples may be collected by wading in a stream by hand from a suitable support or mechanically with a cable and reel setup. The USDH-48 sampler is a depth integrating suspended sediment sampler, sufficiently lightweight for use with wading rod suspension. It is recommended for use in shallow streams where the product of flow depth in feet and mean velocity in feet per second does not exceed 10. The sampler weighs 3.5 pounds and can sample to within 3.5 inches of the stream bed. The USDH-59 and USDH-76 are two depth integrating suspended sediment samplers with hand-line suspension designed for use in deeper streams where wading is not possible. The samplers weigh 22 and 25 pounds respectively. The USD-74 is a depth integrating suspended sediment sampler with cable and reel suspension for use in streams where flow conditions do not permit the use of hand-operated equipment. This sampler weighs 62 pounds. Point integrating suspended sediment samplers measure a sample at any point in the stream vertical. These samplers can also be used to take a depth integrated sample over a range of depths. Point integrating samplers are used to collect suspended sediment samples in streams that are too deep to be appropriately sampled with a depth integrating sampler. The US P61A1, US P63, and US P72 point integrating samplers are in current use. Bed material samplers are of three types. 1. US BMH53, 2. US BMH60, and 3. US BM54. The US BMH53 piston-type bed material hand sampler is used to collect a sample of material from the bed of a shallow stream that may be weighted. The overall length of the sampler is 46 inches. The lower end contains a cylinder 2 inches in diameter and 8 inches long that is pressed into the stream bed to collect the sample. The suction created by the piston holds the sample in the cylinder. This sampler will not work for coarse sands and gravels. Its weight is 7.5 pounds. The US BMH60 is a bed material sampler with handline suspension, used to collect samples from the bed of a stream, lake, or reservoir. Penetration into the bed material is about 1.7 inches. The sampler can be suspended from a flexible line and lowered and raised by hand power. This sampler weighs 32 pounds. The weight of the sampler limits its use to low velocity streams and slightly or moderately compacted bed materials. The US BM54 bed material sampler with cable suspension is used to collect samples from the bed of a stream of any depth. The sample is collected from the top 2 inches of the stream bed in a single scoop-type bucket that pivots out of the bottom of the sampler body. The bucket encloses the sample in such a way that it is not washed out when the sampler is raised to the water surface. This sampler weighs 100 pounds. There are two types of bedload samplers. 1. US BLH84 and 2. US BL84. The US BLH84 is a weighting type bedload sampler used to collect bedload samples from a stream that can be weighted. This sampler can collect bedload of particle sizes less than 38 millimeters at mean velocities up to 9.8 feet per second. The sampler weighs 10 pounds. The US BL84 is a cable-suspended bedload sampler used to collect bedload samples from a stream of any depth. This sampler must be supported by a steel cable and reel suspension system. The sampler weighs 32 pounds. This table shows a comparison of sediment samplers. Suspended sediment samplers determine sediment concentration at a cross-section in a stream. With weighting equipment, measurements can be made down to within 0.3 feet of the stream bed. With cable-supported equipment, the unmeasured zone varies between 0.5 and 1 foot, depending on the type of sampler used. Suspended load measurements consist of 1. Sediment concentration, 2. Particle size, 3. Specific gravity, 4. Temperature of water-sediment mixture, 5. Water discharge, and 6. Distribution of flow in the stream cross-section. The stream flow depth and velocity and the available facilities at the sampling site determine the choice of sampler. Stream depth determines whether hand-operated samplers or cable-suspended samplers should be used. Flow depths over 15 feet require the use of point-integrating samplers to avoid overfilling of the sampler bottle. The larger the product of depth times velocity, the heavier the sampler required for proper measurement. In U.S. customary units, suspended sediment discharge is calculated by this formula. In which Q sub S is the suspended sediment discharge in tons per day. C sub S is the suspended sediment concentration in milligrams per liter. Q is the water discharge in cubic feet per second. In SI units, the suspended sediment discharge is in which Q sub S is the suspended sediment discharge in kilonewtons per day. C sub S is the suspended sediment concentration in milligrams per liter. Q is the water discharge in cubic meters per second. The error in suspended load provided by the measurement varies with the depth of the unsampled zone and the size distribution of suspended load. The error tends to be larger where the vertical concentration gradient in the unsampled zone is large, that is, for the coarse sand sizes. Corrections to account for the unmeasured sediment load can be obtained with methods such as the modified Einstein procedure.